Without further ado, it's already been 15 minutes since I started this live stream, and I might as well do some editing before to actually cut out these first 15 minutes, and we should be doing the intermission. Just confirm that you're still hearing me loud and clear. Alrighty. Okay, so what I actually want to do here is build an artificial intelligence or machine learning application that summarizes articles. So for example, if we have an article, let's go to, let's say, Hacker Noon. Let's go to Hacker Noon. Let's actually look into an article. So you have an article here which is quite pretty lengthy, and we want to give this article to a machine learning algorithm and have it give us a very TLDR version of the article, like 3 or 4 lines or 100 characters of this article being summarized. So there are multiple ways to do this, but right now in the world today you can actually do it really fast, and really it's quite mind-boggling. Today, while doing my homework for this live stream, I've actually looked to see if there are any already made artificial intelligence or if there are already some applications that are done for this purpose, and I found like 2 of them. So TLDR AI app, if I look this up on Google, we have this article summarizer and online text summarizing tool. And there's also another one, this one, but these are actually paid stuff. So it says summarize now, it's free, but they actually have a pricing, so it's not actually quite free. If we try this just by pasting the URL and give us the short concise, and we say summarize this, we get some output from the algorithm. So I haven't actually read this article to see how relevant this thing is, but anyway, this is similar to something that I want to be doing. So they have an interesting pricing plan. So it's not actually too expensive, but still, if we can do it for free. And then there's this another one which is kind of, I don't like the user interface, and it says they're actually based on GPT-3 API, and this is actually not, I don't like the user friendliness of it when it comes to graphical user interface. So anyway, what do you guys think? Are you excited about this? Tell me in the chats. So for this purpose, let's actually pin this. We will be using 2 things. So let's actually break things down from first or actually build things up from first principles like Elon Musk likes to do. We want to be building very fast an AI web application. So for this, we need something that would help us to build the web application very fast, and that's where Streamlit comes along. And then we also need the machine learning algorithm or model that's actually going to help us do the entire processing or the functionality of our web application, and that's going to be provided by the models at the Huggingface. Okay, so for this we'll have to install both of these. First off, Streamlit is a very nice, very nice framework, if I can put it that way, which allows us to extremely fast build web applications with Python. So if you want to actually follow me along, and in this first session I might just want to have these tools installed and then proceed further in future sessions. Maybe we'll start building the backbone of the web application. But I think I want to first introduce, if you guys would like that, just give me a lot of feedback in the chats here. So first off, maybe we're gonna be building a little bit of the backbone, but I wanna like have the basics well established, and I wanna have you understand what we're actually doing here. So if you want to follow me along, I'm on Windows. I think my Python version is 3.9 or 3.8, either one of this. If you want to follow along, do pip install Streamlit. I've already installed it. And then if to actually test it, do the Streamlit hello. To make sure that it works, and then you have it up and running. So you have it here. Okay, the next thing, so this is basically, Streamlit is actually going to very fastly help us build our web application. Like for example, if you wanna like do a data explorer app, this is just a few lines of code. So first off, let me start my Visual Studio Code, and then let's actually do this. So you're importing Streamlit as ST, Pandas, which is a data science library, and NumPy as MP. And then as you interact with Streamlit, and since this is a web app, you just simply do ST title Uber pickups in New York. And let's actually save this onto the desktop as a Python application, as a Python file, and name it, how should we name it? TLDR, of course. TLDR. And then if we want to run this, I think we're using Streamlit. Come on. So we simply use Streamlit TLDR. I think so. Maybe we need to do the Py thing as well. Let's see. What about TLDR? Probably not, because we're not on the desktop. So streamlit tldr.py. No such command. Interesting. So let's look into the documentation. It's Streamlit run. So it's Streamlit run tldr.py. So that's how you actually run it. So the only thing that we've done for this basic application is to set a title called Uber Pickups in New York City. And let's see if we do an S and then save, how fast is it actually going to? Extremely fast. So this is what I'm talking about. We need something to actually allow us to deploy an application very fast, so we don't have to worry about layouts, about how things are arranged in the page, about all sorts of stuff. This should be our less concern. Our main concern should be to optimize the way our AI web application performs in terms of functionality, and not have to deal with the way it looks. Because as far as I've seen, there are these Streamlit apps are really beautiful in terms of a user interface. So you could also deploy this app. So once we have it finished, we can have it deployed in their, I think it's the gallery or the sharing. Yeah, and if you look into the gallery, there are people who have been posting their apps here, and this is my purpose as well. So once we have it up and running here, we're probably going to deploy it to my GitHub. And then I'm just new to this, so this is the first time I'm actually doing it. So I am learning and you're learning. We're learning both at the same time, all of us here. So we're probably gonna put the application here as well. So if we look into, let's say, go to the application, to this one, as you can see, it's been is not working. Let's try another one. So will you look at that? This is the power of Streamlit. Maybe we can look into the source code as well. Can we see the code? I think the code was actually here. View the source code. So yeah, we have the source code already deployed on GitHub by the person who actually, this is actually by Streamlit. We can see the Streamlit app.py. So this is a single file. This is a single file web application, and I actually love simplicity, and this is what I'm actually looking for. So Streamlit, to reiterate, how many of us are here? Harsh. It doesn't actually use GPT-3 because Streamlit does it. Streamlit is not actually regarding the part of, so Streamlit only deals with the web application itself in Python. When it comes to the machine learning feature is going to be added by Huggingface. So that's what I was explaining. First, you have the Streamlit, who allows you to build a web application in Python very simply, and then we use the machine learning from the Huggingface. And in this case, I'm going to explain Huggingface now. So we're gonna leave this here. Okay, so is it clear for you so far? Now, Huggingface. This is actually another platform that has models and data sets I'm not sure how far or how deep all of you watching have an understanding of machine learning models. So in this case, the models that are posted on the Huggingface, this is like an aggregator of models. These are actually machine learning models that have been trained on huge data sets. So we have the trained algorithms and we can simply use them by installing the Huggingface Python package. So all of these models, like for example, let's look at this one. So Huggingface is an aggregator of natural language processing models. And one of the most interesting ones is the GPT-Neo one, which is similar to GPT-3, but GPT-3 is still behind closed doors. So we have the GPT-Neo, which is an effort made by Eleuther AI, I think. So Eleuther AI, an implementation of model and data parallel GPT-3-like models using the Mesh TensorFlow library. So we have this GPT-Neo model, which is similar to GPT-3, already posted on the Huggingface as a model. So if we install the Huggingface package on Python, we can use the GPT-Neo model, which is extremely powerful. Now, the model that I've delved into is the Dilbert, and this model is a distilled version. So this is a transformer model. If you don't know what transformers are, these are types of algorithms that have getting a lot of popularity in the last 2 years, most specifically in 2020 and 2021. GPT-3 is a transformer model as well, but there are a lot of amazing other transformer models out there. So this was the Dilbert. Distilled BERT is a smaller version of BERT, and this was pre-trained on the same data, which they call corpus, using the BERT-based model as a teacher. This means that it was a pre-trained on the raw texts with no human labeling. So I'm not actually sure what this has been exactly trained on, what types of text, because GPT-3, I'm not even sure what GPT-3 has been trained on. But if we look into the paper, for example, maybe we see what this was trained on. Probably says in the paper. Explains the architecture here. This is a very introductory paper from 2019. I cannot see where it says. So we train distilled BERT on the same corpus as the original BERT model, a concatenation of English Wikipedia. So they took the entire English Wikipedia and the Toronto book corpus, and they trained the distilled BERT and also the BERT on this one, and they used 8 16 gig GPUs for 90 hours. So if we're gonna be doing the same thing, think of it like this: if you would be trying to do the same thing, it's gonna probably cost you a lot of money. So in this case, we are very thankful for these guys for training and giving us the model, which was updated on December 11 for free. And what we can do in this case, we can just take the model, instantiate it in Python, and then make use of it. So I'm not actually really sure let's see what this model can be used for. How to use? You can use this model with a pipeline for masked language modeling. But in this case, we're not going to be interested in the Dilbert. Let's actually so I've said that our focus is going to be article summarization. And in this case, we're going to look for models that have been used for summarization. We'll just filter for summarization, and here are the models. We have 212 models which are sorted by most downloads. We can take either one of these ones. Yes, Harsh. That's right. So it's not only that it was trained on millions of different books, but I think it was trained on other things other than books as well. So we can look at, I mean, GPT-3. What is GPT-3 trained on? Unlabeled text dataset. So first it was trained on Common Crawl. It doesn't say much. What about here? It doesn't say here either. If we do trained on, so GPT-3 was trained on hundreds of billions of words and is capable of... It doesn't say here either. Damn, I gotta, like... Maybe the OpenAI weren't very transparent in telling people what GPT-3 was trained on. I'm just saying. GPT-3 was trained on a mix of 5 different corpora, each having certain weight assigned to it. Maybe the GPT-3 paper so the 5 datasets used were Common Crawl, Web2Text, Books 1, Books 2, and Wikipedia. Books 1 and Books 2 were probably the millions of books that you were talking about. Harsh. So I would be curious to see if we can get more specific into that. But anyways, we are actually deriving from our main topic here. Are you still following? So the Hugging Face is gonna give us the model that's gonna help us summarize articles. So in this case, if you do not have the Hugging Face installed, we can look into the resources and we can actually do the, let's see, Transformers documentation. But I want to actually open this up into a new window. Okay, so we will be looking for something that has to do with summarization. Getting back here, we have the Facebook one, Bart Large CNN. 103 downloads, and we have this still Bart CNN. I think CNN stands for probably convolutional neural network. Let's see what this is all about. And in this case, you can test it here on the Hugging Face platform. You provided a text and you give compute, and it actually gives you a simplified version, a summary of this text. Like for example, if we take text from here, if we copy text without let's say we copy, let's see if we can copy this much text. And say compute. It's probably gonna take a little while if it's being computed. Interesting. So we have the entire text computed in 1, 2, 3, like 3 sentences. We should probably check the validity of that, but the point is not to actually read this entire text and see if the summarization was good, but what we actually want to do is to implement this and actually make a web application out of this, like I said here. So the next thing would be to actually install transformers, to actually install Hugging Face on your device. So in this case you would do pip install transformers, and it would be advisable to have either PyTorch or TensorFlow installed on your system. So I've already installed transformers. If I do a pip list, I have the transformers, and I also have the PyTorch, and I also have the TensorFlow here. So I would say that I'm good to go. Now, to be using the distill BART, what is it that we need to do? We should probably, so the usage will probably download one of these we have a Rust model, we have a PyTorch model, and these are actually the biggest ones. So it's probably gonna download the PyTorch model when we instantiate it in Python. So we have to be looking into the BART documentation and see how to actually use it. Let's see if there's summarization here. Summarization examples. So we feed in the article. First we import it in Python. Then we take the BART large CNN. I wonder if this was the one that distill BART large CNN. So we have the large CNN, but in this case we're actually going to use the distill BART CNN. Let's actually copy this, then go back, then open up the docs. So we want to be loaded into from pre-trained. Have this at hand. From pre-trained, we're gonna take this one, bar large CNN. And when we run this, it's gonna download the entire model. It's gonna take a little while. But anyway, I'm not sure if you're following along, Harsh, but might be a lot to take in. At least this is for me a lot to take in, because this is the first time I'm actually doing this. Now, let's try and modularize our to-do for a better understanding. First, we use Streamlit to build the web app in Python very fast. So this is for the web application itself. Later we post it on GitHub and Streamlit gallery. Then we use Huggingface to get the machine learning model onto our data. That's what we're actually gonna do. So this is basically the 10K feet perspective of what we do. We have installed, so pip install Streamlit, and then pip install transformers to use the Huggingface model. And then we can start actually building our app. Let's actually do the very most basic and then maybe conclude this first live stream. We'll be starting with the tutorial from here. So we have the title, Uber pickups. Our title in this case is going to be st title TLDR article summarizer. I wonder if it refreshes itself or you have to refresh it. I think you have to refresh it. So TLDR article summarizer. What is it that we would want to be doing next? Let's see, so let's actually take the code from here and get it into our application here. So from transformers we actually import this. This is for actually the machine learning feature. Is there anything that we need to import? No. So from transformers we import BART tokenizer and BART config. Then we download our model. We use a tokenizer, in this case the article to summarize. It's quite simple. If you come to put it that way, I mean, it shouldn't take too long to actually write this this web application. Let's just say that article, and then tokenize the article, and then generate summary. You generate summary. These are some parameters that we could be playing with later on. And instead of printing the tokenized decode, we could just, let's actually run this, see what happens. It's gonna take a little while because it has to download the models, 1.6 gigs. So first, but after the initial download of the model, it should run faster. What I want to see is how I would actually post the result of the article summarization using Streamlit. Probably with st.write. So you can use specific text functions to add content to your application, or you can use st.write and add your own markup. We don't want to be, we just want the very basic. So st.write, this is what we're gonna use. We're already 53 minutes in. And the model is like 50% downloading. So again, in here what I want to later do is, instead of me hard coding the article, I would want to take the article as an input from here. So actually have a text box here where you can paste your article, and then push a button here, and when you push the button, I would actually run the article that you've inputted through the model and then give you the output. This is what I actually want to take things to ultimately. So you're saying that you stop following midway. Do you actually understand what I'm saying here? At least maybe 40%? Okay, Harsh. I'm glad I'm not talking by myself here. Let's see if the model is downloaded. Yes, so we have the model downloaded. And it's still executing. So once the model has been downloaded, so it's still downloading some other files. It's finished. Let's paste something else in the article here. Let's try to paste this. And then save this and see if we can do, instead of print, st.write this entire thing and then refresh our application. As you can see, it's running. We're gonna do, if we do get some output, we're gonna work with this max length thingy. So it's still running. And we have some output here. It's not nice, but it is something. And that's slat. Truncation was not explicitly activated. We do truncation true. Let's do max length 100. and maybe thereafter play with the truncation. Okay, we have something here. Let's see if it's the same thing as our output. So our input was this. Back to Slack for a moment. According to 2018 magazine profile, this may be something that we're actually, this could be something really good. So if we look here and read this, according to 2018, the problem posed by plastic pollution first caught his attention when at age 16 he saw more plastic bags than fish during a diving trip to Greece. He set aside his aerospace engineering studies to found Ocean Cleanup. He now serves as its CEO. And what did our model give us here? Sled set aside his aerospace engineering studies to found the cleanup in 2013. Wow, that's freaking awesome. He now serves as its CEO. Wow. According to a 2018 Time magazine profile, the problem first caught his attention when at age 16 he saw more plastic bags than fish during a diving trip. This is amazing. So because I have specified the max length to 100 tokens, we probably have 100 words in here, and this has actually been, the model has been doing a very good job in actually summarizing the article. But if I would like a TLDR version, I could simply ask for max length 30 and see what we get in this case if we refresh our page. And while this is running, I want to set up some to-dos for the next session. So to do next, have a box input on the web app to get the text that we want the TLDR for. Have a button to push and initiate the machine learning processing, and 3, have an output box to give us the result, aka the TLDR. And then maybe 4th, do some beautifying of the interface, like maybe adding a sidebar and maybe some fancy stat widgets. I am freaking fascinated by this. So in this case we got the 30 words version. Sled set aside his aerospace engineering studies to found the Ocean Cleanup. He now serves as its CEO according to A. Now in this case it just gave us our previous summarization and it truncated it to 30 characters. But there are parameters in our model here that we can work with, that is beans stopping, that we can actually have it give us a different output not the same output but truncated. So we'll be probably working with this as well in a future session, but I'm actually really excited by this, because if we can use these very big models from Huggingface that have been trained with millions of dollars by big companies, what we can do is unlimited. We can not only code for summarization like here, but we can also code for question answer models. Like we give it a model and then we ask a question to the model and then it gives us an answer. Or what else? Let's see. I think it's general utilities. Or summary of the tasks. So we can do sentiment analysis, question answer. We can do masked language models. We can do text generation. So we give it a short text and it's going to generate a lengthier one. Name entity recognition, I don't know much about this. We can also do summarization like we've been doing here. Text translation, so this is actually awesome. I'm really excited about the question answering thing and also about the summarization thing. So maybe we'll be focusing on all of them in future sessions. Okay, so yeah, it's better than humans, Harsh. So I guess I'll be ending this live stream here. I think it was a successful first live stream, and then we probably might be continuing with it in the future. So Harsh, this was a one-on-one session, so you have to feel the exclusivity that you've had here. Hit me up on Twitter so we can discuss about live streams on the other channel and about moderating. Okay, have an awesome day.